Get rolling. Hey, Akamai Edge World, how's everybody doing today? Good. My name is Bob Strecansky. You can find me on Twitter at Bob Strecansky and on GitHub too. Today I'm here to talk to you about establishing some more best practices utilizing Akamai and other internet technologies. All of these slides that I have up on the screen today will be available after my talk. There's a link at the end of my presentation with the slides, so don't feel like you have to take pictures today. One of my core tenets of my talk today is Akamai is more than just a traditional content delivery network. You should use it as part of your core infrastructure. Lots of things that you can do on Akamai will really help you to evangelize your business. So let's first a little bit about me. I went to Clemson about a decade ago, go Tigers. Then I started in the consulting world at Capgemini for a couple of years. And then I worked at this small company, you might have heard of it, called Akamai. Right now I work at MailChimp as a senior site reliability engineer. I help small and medium-sized businesses market effectively and in turn grow as companies. So we're going to talk about a couple things today. We're going to talk about how to use Akamai and Kubernetes together effectively. We're going to talk about continuous integration and continuous deployment with Akamai in mind. And we're going to talk about BigQuery as an ingestion point for data stream. So the first thing we're going to talk about is Kubernetes and Akamai together. I want to poll the audience. Who here uses Kubernetes in production? Who here is thinking about using Kubernetes in production? Good, good. Who here runs their own on-prem bare metal Kubernetes install? We did that. Don't do that. So we're going to go over a little bit of a glossary first, just to get everybody up to speed on Kubernetes. The first and most atomic unit of Kubernetes is a container. A container is as small as you can get. It's where your application code and some of the dependencies that you need to run your application code live. Docker is commonly used in Kubernetes, but there are also other mechanisms that you can use instead of Docker if you'd like to. A pod is the smallest object in Kubernetes. You know those containers that we just talked about? Pods allow you to abstract those in a meaningful way. We'll talk a little bit about more about those later. And a node is a physical machine, either physical or virtual. And this would be the equivalent of a bare metal host or a VM in the cloud. And a cluster is a set of nodes. This is what you traditionally think of as like a data center or like a group of physical hosts or whatever. So you might be asking yourself, why Kubernetes? Why should I learn this new technology? Why is this important to me? And why is it important to my business? So what's really nice is Kubernetes allows a really great separation of operational and development concerns. For many years, we would just throw things over the fence. Operations people would go to developers and say, hey, your code is non-performant. We can't keep up with the load with our infrastructure. And inversely, developers would say, hey, operations people, I noticed that this isn't running the way that I expect it to. Can you help out from an operations perspective? We don't have to do this anymore. Kubernetes helps abstract these things away with a couple of really neat pieces of technology. So one of the core tenets of Kubernetes is observability. And Kubernetes has really great APIs that help you to see what's going on in your cluster in a meaningful way. There are many tools that are available that are free and open source that can help you out with your cluster, such as Prometheus, Sysdig, Google Cloud Monitoring, Stackdriver, so on and so forth. So within Kubernetes, we have node metrics, which are probably the most important. So what node metrics do is they give you the ability to see how your individual nodes are being handled at a specific time. So in this particular screenshot that I took, you can see that we have 55% CPU utilization. This is great. You can know how much of your infrastructure is being actively used. And then you can see the number of CPU cores that we have available and that are being utilized. Again, we know when we need to scale up, when we need to scale down. This is really effective. We can also see how our CPUs have been doing over time. So as we get big workloads, or we have floods of customers, or we have an influx of traffic, whether good or bad, we can see what's going on with our infrastructure and tune accordingly. We also have the ability to see metrics for individual nodes, so CPU utilization, memory utilization, network throughput, and disk usage, All of these statistics really help us to understand what's going on within our infrastructure and how we can scale it effectively. Another really great piece of Kubernetes is its best-in-class resource isolation. Who here has had a small portion of bad code destroy their entire infrastructure? Who here has gotten woken up in the middle of the night because a Java process leaked memory and you had to restart it? If I had $1 for every time that happened to me, that would be great. So Kubernetes can help out with this. Kubernetes allows you to set resource limits for specific hosts and specific services, and it allows you to restart containers that are acting poorly. This is great. You know that Java process that I just mentioned? When it runs out of memory, you can just have it restart itself. This is nice. Or you could say, oh, I only want to give this particular service 4 gigs of memory and 4 gigs of RAM because I know that's all it should ever really be using. If it's using more than that, something's wrong. So this really helps you to separate your operational and development concerns. Here's an example pulled from our GitHub repository. In this particular example, we set 2 physical CPU cores and 2 gigs of memory for this particular process. If we decide we want to change that later, it's as simple as going in, changing these couple configuration lines, and pushing it out. So we can scale as we need to, but we can make sure that this particular process isn't eating something else up. This is really nice. It really helps us to separate our business concerns from one another. So resource sharing is another really big core tenet of Kubernetes. So for a while, we treated our servers as pets. We would feed them, we would pet them, et cetera, et cetera. And we decided that this was not tenable as we started growing these computer systems that had tens of thousands of physical nodes altogether. Then we went to VMs. VMs sort of partially helped us because you could put more than one virtual host on an actual physical host. That sounds great. Sign me up, right? Cool. Then we started working on different hypervisors. So like we had the libraries and the guest operating systems all running in the same VM container. And then we had physical infrastructure that was abstracted away from that. That's also good. And then configuration management came up next. Chef, Puppet, Ansible, Salt, whatever you want to use. They all do the exact same thing, essentially. They all give you the ability to run big jobs on all of your hosts at once. You want to add a new user's SSH key to every host in your fleet. You want to change the permissions of your Verilog Nginx directory because you feel like they're too open. Great, configuration management can help you with this. This helps you scale out your infrastructure more impactfully, right? So next, containerization was the next biggest step here. FreeBSD jails were introduced in FreeBSD 4.0, which was March 14th, 2000. That was almost 20 years ago. That's crazy to think about, right? Containers have always been cool, but they haven't been well evangelized. Docker really helped with this. It just gave us the ability to separate our concerns from one another. So Kubernetes is the next step in this evolution. This is a diagram tool called Spect8 that allows you to see all of the different processes and services and containers running in your infrastructure. This is a really helpful visualization tool to see how all of your nodes are interconnected. It also can be really helpful when you say, oh, wait a second, we spun up that business process temporarily. Oh, but temporarily was 2 years ago. Shouldn't we have shut that down now? Having this kind of unique visibility can be really helpful for you as your business grows. So Kubernetes sounds really cool and whatever, but we're not at KubeCon. We're at the Akamai Edge conference. Why are we talking about this? We're going to talk about how you can use Akamai effectively to leverage all of the really neat things that Kubernetes has to offer. So we're going to talk about setting up fast DNS, about caching static assets effectively, using GTM failover, and using Kona, and setting up alerts effectively. So Akamai's fast DNS and GTM products help us with DNS management for our Kubernetes cluster. Having Akamai act as your primary DNS provider can take a lot of operational toil away from you because they can just act as your DNS management, which is really nice. They also have really great APIs for being able to update DNS programmatically rather than having to go in and physically do it by hand. This can really help eliminate some of the danger in DNS configuration. As we say, DNS is the house of cards on which the internet is built. And anything we can do to facilitate the change of DNS is a good thing in my book. So weighted load balancing is one of my favorite pieces of Akamai technology, and it's not often evangelized. So weighted load balancing allows you to split traffic between data centers. And when one of those data centers isn't functioning exactly as we'd expect it to, we can serve traffic from the other one, or we can serve traffic from an alternate location. So you know those 2 new Kubernetes clusters that you just set up? That's great. What if the first one needs to go down for maintenance? What if some physical hardware broke, or you want to update to a newer version of Kubernetes? Using Global Traffic Manager can really help you with this. You can just shift all of your traffic over, again, via a really neat API, programmatically, do the maintenance on server set A, then migrate over to server set A, make the changes on server set B, and then split the traffic again. This is a really great way to be able to keeping up with updates and all sorts of other things without having a lot of operational toil. So coming up with a health check for your GTM liveness test is really important. We had a lot of discussion about this in MailChimp internally, and we came up with some really neat ideas. The most important question you have to ask yourself is, where does your business need to have the health check live? You could have it live on the application server. You could have it live within your Redis or your memcached instance. You can have it live within your database. You can make sure all of these different processes and services respond effectively, and then give Akamai back a 200 OK response when all of these things are working as expected, and a 500 if it's not. Or you can just determine what part of the app is most important for your end users. Is it OK if you serve this particular piece of content with nothing from the database? Is it OK if you serve this particular piece of content without something from your memcached instance? These are very important things to consider when you're trying to decide which health check object to use. So Kona can also really provide great insight in your application. As we scale out these Kubernetes clusters, they can get expensive very quickly, especially if you're using a managed offering. Auto-scaling and just the sheer amount of hosts that you can run in these cloud infrastructures is wonderful. It allows you to sleep at night. It allows you to not have to worry about rapid growth, but it can also just unbounded grow. So you could wake up in the morning and you could have auto-spun up 1,000 more VMs. Guess what? Your boss is going to be sort of unhappy with you when you get that $10,000 extra bill the next month. So this is where Kona can really come into handy. Kona's DDoS mitigation strategy is really great, but it can also show you when you're having an issue. Something bad happened right at that peak, right? You can see it pretty quickly from this diagram. And this is really nice to have this visibility, to understand when your infrastructure is seeing something that you don't normally see. And being able to have this kind of visibility can help you make the right choices within your infrastructure, whether it be Kubernetes or not. The other thing that's really helpful is Prolexic. Prolexic stops everything else. If you haven't thought about using Prolexic, it's probably a good idea to. They are able to help with mitigating things that are not on 80 and 443. They're able to help with things that are not running on HTTP. If you haven't taken a look at it, I would highly recommend it. It's helped MailChimp a lot with our operational toil. Last, but certainly not least, set up some alerts in the Akamai portal. If you take one thing away from this talk today, do this. This takes 10 minutes, maybe. And what's really nice is you can have all sorts of alerting come back to you, whether it be for customer data center down, like if one of your Kubernetes nodes goes down, or if a customer server was removed from rotation, like you wanted to do some maintenance, or if you want to worry about edge errors. This is a great place to set up this alerting. I've seen this happen too many times as an Akamai employee and as a MailChimp employee, where the alerting infrastructure also sits along with the application infrastructure. So when your application goes down, you also don't get alerted about it. This can be very, very tricky, and it can also cause a lot of undue stress for operators and developers alike. So go into the Akamai portal, set up some alerts, and send them just to yourself, at least for first. See where you are having gaps and where we can help to improve them. So next, we're going to talk about continuous integration and continuous delivery. Continuous integration is a method of software development in which code is integrated in a shared repository, checked, and deployed all the time. Continuous delivery is where all the different aspects of software configuration updates can be delivered safely and effectively. These two topics are often talked about together because using them harmoniously allows you to deploy software more quickly and impactfully. So MailChimp had a paradigm split a couple of years ago where we went to deploying tens of times a year to about 100 times a day. We're deploying over 100 times a day at MailChimp now. And continuous integration and continuous delivery has helped us with that. This is really great. It has helped us to keep up with development momentum. It's helped us to catch bugs earlier before they harm a lot of customers. You don't have that Saturday morning deployment where everybody has to come in the office begrudgingly and push out a bunch of code together. Something will break because you're pushing out 400 changes at once for that month. We don't want to do this anymore. That doesn't really scale, and it really takes a toll on your developers and your operators. So continuous delivery has been really helpful for us at this. There's a couple of places where Akamai can help out with this, even though they're not very well evangelized. We can cache your release assets so that your developers can just check on them periodically and make sure that things are working as you expect. You can use WAF to make sure that there's no weird anomalies or nothing unusual happening when you push out this new code, and to make sure that it doesn't impact your end users. Again, Prolexic is fantastic. It can help you with pretty much everything else. And last but not least, make sure you're serving 4xx and 5xx error pages from the edge in case you have an issue, so that your customers can at least get a consistent experience. Continuous delivery is my jam. So this screenshot, taken from our GitHub Enterprise instance, shows you how continuous integration and continuous deployment look from a developer perspective. We can make sure that our documentation is built. We can make sure that our JavaScript tests are run as we expect them to. We can make sure that we have a Jira ticket assigned in the title of your pull request for auditing purposes. We can make sure that our linter makes the code look stylish. And we can make sure that all of our unit tests pass so that we feel like we can push out this code safely and effectively. The possibilities are endless to add here. These are just some examples that I found that seemed relevant. You can add anything as a commit hook in GitHub or whatever version control software you're using to make sure that your code meets all the given criteria before it goes out to the world. So MailChimp has a couple separate services that we use to communicate with our customers. We have a marketing site where pricing information, email sending information, all sorts of other like customer-specific, but not individual customer-specific information gets passed. We also have our administrator portal, where our customers can go in and fine-tune their emails or their Facebook and Instagram ads or their postcards or their landing pages to be able to serve their customers more impactfully. As we continue to work on all of these different facets at MailChimp, we are also growing at a pretty fast pace. So this provides a very unique challenge. We have non-technical marketing people and content strategists and other things that really need help doing technical things, like redirects. When we implemented a new strategy for our marketing site last year with this beautiful Cavendish yellow that's on my slides, we had our marketing team needing to set up a lot of redirects from the old website to the new website. If anybody here has ever dealt with redirects before, you know they're a thankless job. 301s and 302s, and now 307s and 308s are not fun to set up. They can cascade on top of each other. They can take people to the wrong place at the wrong time for the wrong amount of time. So the more we can get rid of, the more we can obfuscate these away from our operations people, the happier they're going to be. So Akamai's Edge Redirector cloudlet helped us a lot here. You can set up specific criteria and behavior to be able to redirect people at the right place at the right time. One of the unsung features about Edge Redirector is you can do a redirect for a specific amount of time. This is really fun. So if you want to set up a Halloween page or if you want to set up an April Fool's page to serve to your clients, you can do that. And you can do it for a small amount of time. This is really nice. Our marketing department has really come to love this. You can even upload an Excel file that has source and destination for redirects, and Akamai handles it all for you. This is really cool. I have a bunch of coworkers that are not interested in going into Nginx and writing a new rule and running Puppet and reloading Nginx and validating all these things. They can just go into this portal and make this change. Another fringe benefit of this is these requests never actually touch our infrastructure, our co-load infrastructure, or our cloud infrastructure. It actually just does all this work at Akamai. This seems little, but it actually adds up a lot. Your these are specific individual requests that your infrastructure has to touch. 1 or 2 may not make a big difference, but when you get to tens or thousands or hundreds of thousands, these redirects can add up very quickly. So recently, MailChimp built a brand new large marketing site, as I mentioned, with this cool Cavendish yellow color. It's pretty, huh? Like it. We really had a great time building this new marketing site. Again, we have a lot of people at MailChimp that are content delivery strategists or make beautiful images for our website, but they don't want to have to go in and rewrite HTML from scratch. Nobody wants to do that, actually. So we decided that we were going to build a new content management system for MailChimp.com. This always has really interesting challenges, and Akamai really helped us to deploy this out safely and effectively. During this project, we set up a new origin infrastructure for the new marketing site. We used Akamai's GTM product to load balance between the old infrastructure and the new. We set up cookie logic within the Akamai Ion configuration to let people that we knew and trust check out the new website before the old website was decommissioned. Spoiler alert, everybody wanted to check this out because our customers are really excited about this kind of thing. And then we created an internal whitelist in our Ion configuration to send all of our internal people to the new website to vet it before we pushed it live to production. Last but not least, we did a gated release for our end users. We started with our hometown of Atlanta, and then we moved to the Southeast, which actually has a really unusual definition if anybody's ever looked at it. Depending on how you classify it, it can either have 9 or 14 states in the Southeast. I don't know, it seemed kind of funny to me. And then we went to the United States and the world. This deployment happened with 42 5XX errors, which we're really proud of. Last but not least, with continuous integration and continuous delivery, we've used Akamai's APIs in some really interesting ways. As you may or may not know, Akamai has a bunch of really wonderful APIs that help you deliver content to your customers safely and effectively. At MailChimp, we have our customers embed all sorts of really neat content into their emails that they send to their customers. This is great. However, there's always a security concern with this. Having third-party URLs can be scary. We have customers that add all sorts of different things, good and bad, to their email marketing campaigns, and it's difficult for us to vet them. If we add in code blocks to sort of mitigate these issues, it's a moving target. It changes all the time. People come up with new attack vectors trying to hurt MailChimp servers. People come up with new attack vectors trying to hurt the potential customers, fake customers of MailChimp. So we figured that trying to do this via code was untenable. So we decided to build a proxy to handle all of these third-party requests. So we built this. It worked great. We were very happy with the result, but our customers weren't for one small reason. The IP addresses of the proxy changed all the time. When you build stuff in the cloud, a lot of the times the IP addresses of the services that are contacting you will change. And this is always an interesting thing, and it's tough to manage. So we came up with what we thought was a really great way to mitigate this. MailChimp built a service with a bunch of buzzwords. We built a Kubernetes cron job that pulls the Google Cloud API for IP address spaces, sends a notification to Slack as a bot to make sure that those IP address lists get updated. And then we actually publish that using Akamai's fast DNS API as a text record that our customers can look at and see if they're expecting traffic coming from a different location, or they can programmatically pull that via an API request and update their whitelist accordingly. This has been really helpful for our operators. It's been really helpful for our support staff talking to our customers, and it's been helpful for our customers too. Everybody's been happy with this solution. The last thing that I'm going to talk about today is BigQuery as an ingestion point for data stream. So again, let's do a quick overview of some terms. App Engine is a product that Google offers. It's a managed application platform. A lot of people call this the OG serverless architecture. You have the ability to push out a container to App Engine, and it'll run your code effectively. Cloud Pub Sub is a real-time messaging queue, sort of like RabbitMQ or Kafka. Put in data, take data out, fun stuff. And Cloud Data Flow does stream and batch processing in Google Cloud. Google Cloud Storage, or GCS, is very similar to Amazon's S3 offering. It's just a file store in the cloud that's really, really scalable. And last but not least, we have BigQuery. And BigQuery is a data warehouse that is very inexpensive and very effective for large, large, large quantities of data. You ever have this happen to you while you're working on looking at your data? It feels like you're drinking from a fire hose, as we say. So one of our principal engineers at MailChimp decided that we needed to have a way to ingest this data effectively. So the MailChimp application generates a ton of traffic. And being able to grok this data has been difficult. So we decided to build this product that our principal engineer called the Firehose. So the Firehose takes the incoming request data and does a lot of really neat things with it. So we start at Akamai's data stream product. Akamai's data stream product sends back batches of JSON responses, or it sends us batches of JSON that show us the requests that have come in from the edge. From there, we take that information in through the Google App Engine ingress. We push it down to the pub subtopic to make sure that we can have a publish subscribe method to ingest all of these different pieces of data. Then we normalize and process this information in data flow. And then we store it in Google Cloud Storage and ingest that into BigQuery. So doing this whole process seems like a lot of convoluted work, right? That's 5 additional systems that you have to add in order to be able to ingest this data effectively. We found that this was really effective for us, though. We now have the ability to look at the information that comes from Akamai in near real time. It's about 10 or 15 seconds. And we can see all the requests that are coming in from Akamai, rather than waiting to have to look at Akamai's logs or looking in our Elasticsearch or other people use Splunk clusters. This has been really effective. Initially, we were using the API streaming the streaming API for BigQuery, and then we eventually changed to the batch streaming bits. And the reason that we did that is we found it was quicker for batches, more cost effective, and it added a little bit of latency, but not enough for us to worry about it. So being able to do this in a batch form has really helped us to transform the way we can look at logs. So Firehose has proved time and time again to be a really great way for us to look at things. This project helps us to ingest data quickly. So one thing that I was looking at is who here has used a Nokia phone in the past? Does anybody remember the old Nokia phones? Yeah, me too. I thought they were done, but apparently Nokia decided to put out some new phones recently. So we were interested to see how many of these new Nokia phones came on our platform. So we were able to do a quick query in BigQuery, and within a couple of seconds, 2.9 seconds, 1.2 terabytes of data for the day had been processed. And we found how many Nokia phones had come on our platform. So being able to quickly make data-driven decisions based on that incoming request logic has been really helpful for us. So this Nokia example is sort of contrived, but there are other use cases where this might actually be important. Like your marketing manager may say, hey, do we need to worry about this particular path anymore? Or your developers are like, hey, can we deprecate IE11 yet? Do we get a lot of end users with that? This is the most holistic place we have to look at this information, and it's been really helpful for us. And so recently we had an issue where, like this sad panda, we went, oh no, we accidentally published a bad code push. What was really bad about this code push is we published bad URLs for our customers to publish on their websites. So not only was this bad for us, it was bad for our customers' customers, because our customers would add this new URL to their website, and their customers' customers would get a terrible 404 page rather than getting the information that they needed. So what we did is we were able to go into BigQuery and see all of the customers that we had impacted by this small code change. Luckily, it was only about 46 end customers, so we were able to go in and rectify the situation very quickly, and we were on our merry way. Being able to quantify this impact has helped remove a lot of operational toil, and it has helped us keep both our developer and it has helped us to keep our development momentum. Trying doing that with grep, sed, and awk, or even with Elasticsearch, it would have taken a lot more time. This whole mitigation took us 15 minutes. And most of that was writing copy to the customers and getting it approved. I thought that was really cool. So recently, we sunset our API 1.0. This was a Herculean moment for MailChimp. It was a source of a lot of frustration for both our operational and development teams. And we wondered, how many people are still using this? We can look in our logs and see in Elasticsearch how many requests we get for it a day. But some of those may be malformed. And maybe they never even made it back to us. Or maybe Kona and WAF picked them up because they realized that this was sort of an unusual way to make a request. So again, we were able to look in Firehose and determine, oh, OK, these are the customers that are still using this API 1.0. We could link that to data that we had about our specific customers, and we could contact them directly, rather than having to guess whether or not our customers were impacted by this and turn it off and hope that nobody was really negatively impacted. So one of my coworkers mentioned something really fun about all this. He said, all these transitions boil down to the same root. Find patterns in the requests, join them against your business data, and then all of a sudden, everybody cares about what you found. So today, we've learned about a couple different things. How Kubernetes helps both developers and operations teams bridge gaps while using Akamai. How continuous integration and continuous deployment is helping to push out code safer and more effectively using Akamai. And how DataStream is helping us digest millions of terabytes of data. Thank you for your time and attention today, and I'll be answering questions. There's the slide link if you need it. Actually, I have to update that, so it'll be there.
Hey, Bob, awesome talk. At Lowe's, we're going through two huge transitions. First, we're going from on-prem to cloud, GCP. Second, we're going from an application perspective, we're going from IBM WebSphere e-commerce monolith into microservices, Kubernetes on GCP as well. We use GTM currently to route traffic between our primary and backup data centers. Just curious, at MailChimp, did you look at the phased release cloudlet at all? And do you use the GLB on the Google side for any load balancing on that side?
I actually worked on the Cloudlet team when I was working at Akamai. So yes, we looked at that offering as MailChimp. And we really liked the visibility that global traffic management offered us. The Cloudlet is also really, really nice. And if that were available when we started working on this project, I think we probably would have used that instead. Yeah, instead of GTM. But it wasn't available when we started on this project. So I would advocate for the Cloudlet if possible.
For your connection from Akamai to Kubernetes, what ingress mechanism are you using?
I'm sorry?
What ingress mechanism are you using on the Kubernetes side?
So we actually set up so for ingress from Akamai to Kubernetes, we actually set up an HA proxy load balancer that takes data that is used for an ingestion point. We did that so that we could do rate limiting and a bunch of other fundamental load balancer things that moves into our Kubernetes cluster afterwards. So that's the ingress point that we're using from our infrastructure to GTM, and that also affords us the ability to set a better health check for our application as well.